probability of A is 3/4 and the probability of A intersection B is 1/2. Find the probability of B happening given that A has already happened. Everybody happy with that? Now, if I was to look at this, it would be the probability of A intersection B given that A has already occurred. Is that right? So, if you were to do it by Venn diagram, okay, you can't fill out the Venn diagram completely, but you actually have enough information to make the Venn diagram work for you. So, what's the middle one again? So that's A. What's in the middle? 1/2. Now, what's 1/2? What's 3/4 take away 1/2? 1/4. Now, the honest truth is, I don't know what's on the outside, and I don't know what's in here. But the whole point is, I don't need to know, because I have enough information to answer my question. Probability, what's the probability of B, given that you already know A has already occurred? Well, the probability that A has already occurred is 3/4, because that's the probability of A. And then the intersection is what's in the middle. So it's 1/2 divided by 3/4, and what do we get? Anybody know? People are mumbling, they aren't really telling me. Oh, fine, I'll just look at the market scheme. It's 2/3. And that was worth 15 marks, people. That was worth 15 marks. I cannot believe that. Okay. Now, the probability of A union B is 11/12. Okay? Everybody see 11/12? So what I'm claiming is that if that's 11/12, then the outside must be what? The outside is 1/12. How do I know it's 1/12? Yeah. And all the insides, these parts here, have to add up to what, guys? They have to add up to 11/12. So we're going to do 11/12, and we're going to take 1/4 away. So 11/12, take away 1/4, take away 1/2. So let's do that. 11/12, take away 1/4, take away 1/2. What's the answer for that then? Is it 2/12, otherwise known as a sixth? Who got a sixth? Now, what's the test for independence? Anybody remember the test for independence? How do you prove that something's independent? Nobody in the class knows. And when you multiply them by each other, what should happen? Should be able to be the same as the intersection. It's an investigate if question. It's not a show that question, which means it may or may not equal. Okay, what's the intersection again? 1/2. What's the probability of A? 3/4. What's the probability of B? Oh, sorry. We have to be careful with B, because it's a sixth plus a 1/2. What's a 1/2 plus a sixth? It is 2/3. 1/2 plus a sixth is 2/3. So the probability of B is 2/3. And we're about to get 6/12, which is 1/2. Are they independent? Yes, they are. 1/2 equals 1/2. And that confirms it. Or sorry. Yeah. We did it this way. 1/2 equals 1/2, and that's worth 5 marks, people. Okay, 5 marks. Now, part B. Spinner consists of 4 segments as shown. Each segment is equally likely to be landed on. Okay. Liam, Sorka, and Lee play a game which the spinner is spun twice, and the numbers landed are added together. The result is divided by 3, and the remainder is recorded. Wow. Now, the remainder is 0, Liam wins the game. The remainder is 1, Sorka wins the game. The remainder 2, Lee wins the game. Is it a fair game? Are all 3 participants equally likely to win? Give your answer by relevant calculations. Okay. Let me see. Okay, let's start off with the lowest score we can get. What's the lowest score we can get? Would you agree with 1-1? 1-1? And what's the odds of 1-1 happening? It's 1/2 by a 1/2, which is 1/4. Okay. Now, What does it say we have to do? It says that the numbers are added together, so this would be the number 2, wouldn't it? And then the number 2 has to be divided by what? 3. And what's 2 divided by 3? What's the remainder? Remainder 2. Okay, let's go next one. What about 1, 2? What's the odds of that happening? A half by a, which is an 8. And what happens when we add them together? 3 divided by 3. Remainder is 0. Goes in evenly, doesn't it? Okay, let's go for my next one. Was it 1, 3, is it? Now, that's 1, 3. Listen. It's a half multiplied by what? A quarter, which is an 8. When you add them together, what you get? 1 and 3 combined. What you get? You get 4, do you? Okay. And what happens when you divide 4 by 3? Well, remainder 1. Okay. I probably need to go the opposite direction as well, because what do all these probabilities have to add up to? I don't stop till I get 1, don't I? So I'm thinking is, what's the odds of 2 followed by another 2? A 2, 2. What would that be? Quarter by a quarter. What's a quarter by a quarter? 16th. I'm just going to build this section first, all right? And then what about 3, 2? A 3, 2 is a quarter by a quarter, which is. Now let's add them all together. Am I there yet? Am I? So would you agree that this box adds to a half? Would you agree with that? And these 2 boxes add to 2 16ths. How many 16ths am I away from having every probability? A half is 8 out of 16. I'm currently at 10 out of 16, which means I still have 6 16ths left. I need to find those 6 16ths. I was thinking the opposite way around, maybe. You see, 2 followed by 1, 3 followed by 1. So I was thinking this. 2 followed by 1 will also be an 8, won't it? It's the same stuff, isn't it? Just opposite order. What about 3 followed by 1? It's also going to be an 8. And then I got to do the opposite of this one, which is. I didn't do 1, 1 or 3, 3 either, did I? I didn't do 3, 3. Grant. 3, 3 I'll do as well. What's 3, 3? 1 16th as well, is it? Now, does that get me to the finish line? I still think I'm 1 short, haven't I? So what have I done so far? I've done 1, 1. I've done 1, 1. I've done 1, 2 and 2, 1. I've done 1, 3. Have I done 3, 1? I did 3, 2. I did not do 2, 3. Ever see 2, 3? Didn't do that either, did I? Now, when I add all these probabilities together, and the ones I'm looking for are all these here, what happens when I add all these together? What should I get? Let me remember. We get 1, don't we? Now, here's what we're going to do next. Okay. Let's keep going through them and we find out what the remainder is, all right? So this is a 4, isn't it? So this one we already know is a remainder of. Sorry, I'll write on the left-hand side now. It's getting a bit messy on me here. Okay. That one was remainder 2. This one here is remainder 0. This one here is remainder 1. Adds to 4, that's remainder 1. Adds to 5, that's remainder 2. Adds to what? 3, that's remainder 0. Adds to 4, that's remainder 1. Adds to 6, that's remainder 0. And then adds to 5, that's remainder 2. Okay. What's my odds of getting remainder 0? What do I have to add up? A 16th plus an 8 plus what else? Where's the other remainder 0? plus another 8. Idea what that comes to? 5 over 16. Okay, let's go remainder 1 now. How many times did I get remainder 1? An 8, a 16th. What else? An 8. So 2 8s and a 16th. And anything else? Any more remainder 1s? Nope. Everybody happy with that? What do we get out of that? 5 out of 16. Okay. Remainder 2s. So how many remainder 2s do you see? 1/16th. 1/16th, which is 2/16ths. So I need a new color for this one. So I use pink. 1/16th plus 1/16th is 2/16ths. The next remainder 2 is a quarter. That makes it 6/16ths. So getting a remainder of 2 is actually 6/16ths. So the question is, I'm going to reread the question now because I've actually forgotten what the question even says. Okay, is this a fair game? Yes or no? Why is it not a fair game? Not fair as remainder 2 has a higher probability of success. All right, and done.